Okay, we're going to talk about ellipses today, and you see here on the screen a picture of an ellipse, and we are going to talk about the characteristics of an ellipse. And you can see they have two little bubbles that are pointing to these 2 points right here. One of them is right here, and one of them is right here. And these 2 points in the ellipse are each called a focus, and the plural is foci, and they are important to our ellipse. Now, here's what's interesting about these points. If you take any point on the ellipse, any point, and you go from one focus to that point on the ellipse down to the other focus, the total of the distance you have traveled is a constant. So, for example, this distance that you travel to go to this point is the same distance as if you went out here to this point. That is the same total distance. So, and you know what that total distance is? So consider if you were to go over here to this point, it goes over to here, then back, then all the way to here, right? Would you agree? This little piece here, I'm just telling you, is the same as this little piece here. So that distance in each of these examples is the distance from here to here. All right, it's a cool thing about an ellipse and what defines its shape. All right, so let's go down here to the bottom of the page because we're really going to define the characteristics of an ellipse. And let's get this whole thing on the screen. An ellipse is a kind of an oval shape, and it either can be this way or this way. So this is horizontal. This way is vertical. In a horizontal ellipse, your horizontal axis is your major axis. All right, so we have major axis as one of our vocabulary words. And so over here in this one, the major axis is the vertical axis. And out of the two, there's 2 axes in every ellipse. The long one is the major axis. The short one is the minor axis. So this long one right here is a major axis. And the short one right here, that's your minor axis, okay? Now, we already talked about the foci are these 2 points right here. An ellipse has a center. It has a center to it somewhere, and all the ones we're talking about today have a center on the origin 0, 0. There would be a section that we get to. We're not going to get to it this year. We just ran out of time. That's what is going to happen. So, and that is if the center is somewhere else other than the origin. So it has a center, and that center is an important thing. It also has something called a vertex and a co-vertex. So a vertex is actually on your major axis. It's the point where your ellipse intercepts your major axis. And these points are called negative A0 and A0. So now we've defined A in this scenario. The co-vertex or co-vertices are on your minor axis, and they are 0B and 0 negative B. So we're going to need to define these things when we do this. We're going to need to define A, and we're going to need to define B. And that's what's going to help us write this equation. So let's go ahead to the next page here. And we've got a lovely informational box. And that informational box is going to give us the equation to write a horizontal ellipse and a vertical ellipse. All right, and remember, let's just put a little tiny one here. Horizontal looks like this. Vertical looks like this. All right, here is the equation for a horizontal ellipse. Here is the equation for a vertical ellipse. And what's different between them is your denominators. Which denominator goes with which numerator? Oh God. So the vertices have the A's, and they go with the major axis. And the co-vertices are the B's, and they go with the minor axis. And the foci go with the C's. And we have formulas to figure out A, B, and C. All right? So, let's go ahead and do an example. It says, what is the equation in standard form of an ellipse centered at the origin with the vertex -6, 0, and the co-vertex 0, 3. So here's what we've got. The vertex, remember, that's your A's. Your vertex is with your A's. And you can see that the A is in the X position. So this is going to be a horizontal ellipse because notice over here the A is in the Y position with a vertical ellipse. So this will be horizontal. Horizontal. And we're going to say A equals 6. Now this one says -6, but the other vertex is 6, 0. All we need is the 6. All right? The co-vertex goes with the B. And so we're going to have 0, 3, and 0, -3. So we need to know that our B is 3. All right? So here's our form of our equation. X squared over A squared plus Y squared over B squared equals 1. All right, so let's go ahead and we'll write this. So x squared, what's A? 6. 6 squared is 36, so this will be over 36. Plus y squared over b squared, which is? 3. So b squared is 9. Equals 1. Now, this is interesting, and this is your answer, incidentally. But do you remember in section 10.1 we were graphing ellipses, and we didn't have any ellipse equations with fractions, did we? They had big numbers in them, but they didn't have fractions. Well, you could rewrite this without fractions if you wanted. You do not have to do this for your homework, but I'm just going to do this to show you how they get the equations with no fractions, right? So the way to do that would be to multiply both sides by 36, the common denominator. And when you go to do that, you're going to get x squared plus 4y squared equals 36. And does that look vaguely familiar? It's a plus, so you know it's either a circle or an ellipse, but the coefficients of x squared and y squared are not the same, so you know it's an ellipse. Remember that from section 10.1. So that's how they got the equations you're used to seeing. You do not have to do this to your equations, though. So let's go on to example B down here. What is an equation in standard form of an ellipse centered at the origin with the vertex 0, 5. Okay, now, the vertex being 0, 5 means it's got to be a vertical ellipse because the 0 is in the x position, the 5 is in the y position. So this is a vertical ellipse. All right, and so we can also go down here and say that A equals 5. The co-vertex is B, so B equals 2. And if we go up here to the top, our equation is x squared over b squared plus y squared over a squared equals 1. So we have x squared. Let me move this down. We're going to get rid of our box now. X squared over what's b squared?
4.
B squared.
4.
4 plus y squared over a squared, which is 25, equals 1. So there you go. And if you wanted to get rid of fractions, you would multiply both sides by 100, because that would be your common denominator.
That's not necessary.
That is not necessary. All right? Let us go to the next page. Okay. Now, if you take a look at this lovely little picture of this ellipse here, and it's centered on the origin, and here's a focus and here's a focus, and we're going to have a point right here, and so this distance must be the same as this distance, right? Now, this distance right here is C, and the reason why is because this is the point C0. And this distance right here is also C. All right? And if I make a lovely little right triangle out of it, this distance right here has to be B because this is the point 0, B. 0b. And since we know this distance, when we used it before, was the distance from here to here to here to here to here, and that is the point A0. So that whole distance is the distance 2A, because from negative A to 0 to A is 2A. It's A on one side, A on the other side, add them together, you get 2A. So that means this distance is 2A, so each one of these is A. So now we have a right triangle listed with A, B, and C on it, all from our ellipse. So let me tell you what is true. Out of this, that A squared happens to equal the B squared plus the C squared, using the Pythagorean theorem and what is labeled A, B, and C. If I wanted to know what C squared was so I could find my focus, I would subtract B squared. So I would get C squared equals A squared minus B squared, and that is how I would find my C. All right? So we're going to go on and do an example here. It says, what are the foci of the ellipse with this equation, and graph the foci and the ellipse. Now, here's what we're going to do with this. Would you agree this is not in our standard form with fractions so that we can tell what A and B are? The way we do that is get this side to be 1. And the way we do that, divide everything by what's on this side, which is 225. So divide by 225, divide by 225, divide by 225. And what I end up getting is x squared over 9 plus y squared over 25 equals 1. All right? What is A?
3 squared.
So A is,
3.
the A is 3, because it's the square root of 9. What's B?
5.
B is 5. So I need to find out what C is, and remember, we're going to go and use this formula. We're going to use C squared equals A squared minus B squared. Actually, I think that what we have here is this is actually B and this is actually A, because this is a minor axis. This is smaller than this. And if you go over here and you look at the vertical ellipse, it says B squared goes under the X squared when the B is less than the A. So this is a vertical ellipse. So we have our A and our B switched. So we need to switch these guys. This would actually be B squared, and this guy would actually be A squared. And you'll know, here's how I knew that this was going to be the case as soon as I did it. What's A squared minus B squared? It's negative, right? So you know it's got to be the other way. So A squared minus B squared is 25 minus 9, and this gives us 16 equals C squared. So C equals 4, right? Okay. So as a result, our focus is at 4. And since this is a vertical one, you'll find that your focus is 0, 4, and 0, negative 4 on the y-axis. So 0, 4, 0, negative 4 on the y-axis. And your major axis is 0, 5, 0, negative 5. And then you're going to have 3, 0, and negative 3, 0. And we can draw our ellipse from this. Pretty well anyways. There we go. Lovely little ellipse. Okay. Let's go down here to this last one. What is, what?
Do you know which one was on the next line?
What do you mean, that this was B and this was A?
So is B always going to be on the x-axis?
The B is always the smaller one, because look at this. Your B goes with your co-vertex, and the co-vertex is on the minor axis. A goes with your vertices. Your vertice is on your major axis. A is always bigger than B. So whichever one is bigger is your A, and whichever one is smaller is your B. So that's your general rule. So if we go down here to this guy, this is a horizontal one. And what is C? Remember, C goes with your focus.
Negative, plus 1, 5.
So we have C equals 5. And it's on the same axis here, so this is our major axis. So this is A, and A is going to be what?
8.
8. All right, so A is 8. So we need the standard form of the equation, which is going to be x squared over A squared plus y squared over B squared equals 1. But we don't have B, right?
So we need to do the 5.
So we're going to do the C squared equals A squared minus B squared. So C squared is 25. A squared is minus B squared. So subtract 64 from both sides. And I've got negative 39 equals negative B squared. So B equals the square root of 39, right? And what's b squared?
7. What? No.
B squared is 39, right? Divide both sides by -1. B squared is 39. Square root both sides. B is the square root of 39. All right.
Wait,
All we're going to do is plug A and B in here.
I'm confused
So,
what just happened now.
X squared over A squared. And what's A squared? A squared, 64, plus Y squared over B squared, which is equals 1. And there you go.